Good day, guys. Alright, so in this video, I want to talk about how you can apply Kirchhoff's laws to solve problems with complex circuits. What I mean by complex here is that sometimes for resistors, you don't know if they're in series or in parallel, and then when it comes to EMF, you might see multiple sources of EMF, right? So I will be showing an example. However, I would like to emphasize here that there are general rules or general steps that you can keep in mind, keep in check. All right. So let's look at those steps. Step number one, look for junctions. All right. Whenever you see a junction, label the currents going in and going out, and then you use Kirchhoff's junction rule. All right. The second step is to look for loops. Remember, loops is when you take a path, you begin somewhere, you take a path and you end where you began, right? End where you began, all right? And then along those loops, right, you think about the voltage drops across resistors or any other passive components, okay? All right. And then the last point or the last step is once you have done step 1 and step 2, you will find yourself having a simultaneous equation problem. Now, just to mention that whenever you have a simultaneous equation problem, you should have equal number of unknowns and equations. That means if you have two equations, you should have two unknowns, or it's the other way around. If you have two unknowns, you have to have at least two equations to solve the problem. All right, so let's apply that. Okay, so we have our circuit, we have our command. It is telling us to calculate the current through each battery. All right, so let's look at that. Through the first battery, I'll just call I1, and then through the second battery, let's call that I2. If they all move together, right, I1 and I2, they will meet at C, and that's called a junction, right? So let's expand a little bit. There we go. That's it. That's the junk. All right. So we have our junction at C. We have our current I1. We have our current I2. All right. And then once we have ingoing, we have outgoing, and that's I3. All right. So if we remember our Kirchhoff's junction rule, we have all of the ingoing current must be equal to the summation of all the outgoing current. Okay, so that means I1 plus I2 should equal to I3. All right, of course you can rearrange this to have like, oh, I1 equals to I3 minus I2 and so on and so forth, but let's work with this one for now. All right, so let's look at the second one, which is loop. All right, so with this particular diagram you have three choices of loops. The first one, DCEFD, so DCEFD, right? And the next one, ABCDA, so ABCDA. Remember, a loop is when you end where you began, all right? And where you begin, actually, grammatically speaking. All right, so and then the third one, we have ABEF, right? ABEFA. Okay, so just a tip, right? Whenever you have choices of loops, think about it. Would it be easier for you to solve problems with only one EMF or two EMF? I think we both know the answer, and we both agree that the answer would be one, right? So one. Let's choose these two loops then. And let's, for now, ignore the third one. Okay? Alright. So let's look at the first loop that we have. ABEFA. Alright. So that's nice. ABEFA. Now if you remember, Kirchhoff's voltage law or loop rule says that the summation of all the EMF must be equal to the summation of all the voltage drop. Right? So we only have one EMF, and that's the 9 volt. That's nice. And then we have voltage drop across two resistors. So the voltage drop across the 18 ohm resistor and the voltage drop across the 3 ohm resistor. Right? So now we can remember, or we can remind ourselves, we know Ohm's law equals, which is V equals to IR. Okay, so that means across the 18 ohm, and then I have I1, the current I1 going through it, and then I have 3 multiply with I3. Okay, now remember what we did before? I3 is equals to I1 plus I2, right? We can substitute that in, and what we will find is 18I1 plus 3I1 plus 3I2. Let's simplify that. So that's 9 plus 21I1 plus 3I2. Alright, so that's our first equation. So that's going to be our first equation. Alright, okay, so next loop. Okay, there we go. So we have D, C, E, F, D. Alright, again, the summation of all EMF must be equal to the summation of all the voltage drop across each resistor. Alright, so we have 3 volts for our EMF, we have the voltage drop across the 6 ohm, and then we have the voltage drop across the 3 ohm. Okay, and again, Ohm's law tells us that it will be I2 times 6 plus I3 times 3. Alright, so expanding that, I will have 6I2. I'm going to write my 6 better. 6I I2 plus 3I1 plus 3I2. And that gives me 3 equals to 3I1 plus 9I2. Alright, so that's our second equation. Great, now we have both equations. We have two unknowns and we have two equations. That means we can solve them. Alright, so let's list them down. Alright, so now let's look at how we can solve simultaneous equations. The most simplest of them is to look at the constants in front of the variables and to find if we can make it common, right? So if I look at equation number 1, I can make this 3 to become a 9, right? If I merely multiply it by 3, multiply the whole equation, not only the 3, but the whole equation. So that means I can take equation 1 and then multiply it by 3, all right? So that gives me, so 9 times 3 is 27, right? 21 times 3 is 63. I1 plus 9I2. Alright, cool. So I can rearrange this. I can get 9I2 is equal to 27 minus 63I1. Okay, nice. I can also rearrange equation 2 to get, so let's see, 9I2, so that's a Q. 9I2 equals to 3 minus 33I1. So because they're equal, I can take these two and equal them and make them equal, right? So I'm just going to change colors here. So that means 27 minus 63I1 is equals to 3 minus 3I1. I'm going to rearrange so that all the ones with I1 is on the right and all the ones without I1 is on the left, all right? So that's 27 minus 3 is equals to 63 minus 3, and they all multiply by I1. So that gives me 24 equals to 60 I1. That tells me that I1 must be 0.4 ampere. Okay? Okay, good. So once we have that, right, we can substitute this value into here and output something for I2. So that's 9I2 is equals to 3 minus 3. So I know I1 is 0.4, 0.4, right? So that's I2 is equals to 3 minus 3, 0.4. I divided by 9, and what I will get is, drumroll please, 0.2 ampere. So I know my I1 is equal to 0.4 ampere, and my I2 is equal to 0.2 ampere. Very easily I can deduce, because we're all smart at this point, aren't we? So we can say that I3 must be equal to just adding them up, so that's 0.6 ampere. Alright, so there we go, we have done it. Alright, so give this a try, and then I'll see you in the next video.